Hello people, in this video I will provide a quick tutorial on how to use the package MaJoDo for creating a simple real-time server. The main purpose of this package is to create a real-time game server, but nothing is stopping you from using it as a regular server for, let's say, chatting or calling. Even though for calling and these activities I recommend you using WebRTC. If you're interested in something like video or audio conferencing, you can head over to the link in the description where I put the link to this project. This project is called Roletta and it's a web app which I created for the purpose of learning how WebRTC works. This project is a bit old, but I updated it recently, so now it works with today's versions of packages. Its main purpose is to make coding interviews easy, so feel free to check it out and check out the GitHub repository if you want to learn how to make that. Back to the topic of MaJoDo. MaJoDo supports three types of client-server communication: UDP, WebSockets, and WebSockets with protobufers as the serialization technique. No matter which protocol you choose, the logic of the server remains the same. You can think of the protocol as just the tunnel for passing the messages. And by logic of the server, I'm mostly referencing the token-based authentication, or the way that clients are joining rooms. So firstly, the user sends a HTTP request to this endpoint. That endpoint returns a response which contains a JSON web token, and in that JSON web token there is the room name. Keep in mind, the room has not yet been created. After that, me as a client, I am sending a request using the networking protocol I chose beforehand. If the message contains a valid token, meaning the server provided it to the client, the server will decode it and create a room with the name contained within the token. If everything goes smooth, server returns a response which looks like this. From this point forward, every message you send using the chosen communication protocol will be broadcasted to that room and to all the players which are a part of that room. User identification is in the form of IP column port, so that's also how it's stored on the server. Also, if the user is idle for a chosen period of time, which you can of course configure, he will get disconnected, and if the room is empty, the room will get removed. In this section of the video, I will show you how to set up a MaJoDo server. First thing you need to do is to create an environment file which has the JWT secret field in it. This will be used for encrypting JSON web tokens. After that, we can install the package. So let's install it using npm install MaJoDo. Now I'm going to create the MaJoDo server. So firstly, of course, we need to import the MaJoDo package. After that, we are going to initialize the MaJoDo server, but not yet start it. This is done using the constructor for the MaJoDo class. Right now, in this constructor, we are saying that we want a WebSocket server. We don't want protobufers, of course. We are listing on all interfaces. That's what 0.0.0.0 means. And we want port 3000 for the HTTP server. If we wanted a UDP server, we would change the first argument from WS to UDP and add a fourth argument, which would be the UDP server port. Right now, we need to start the server, and that's as simple as writing majodo.start, and this is sufficient for running the server. But we will use two more functions, so we get more functionality from the package. The first thing we are going to do is get access to the Express server and create a new endpoint, which will just return hi to us. The second thing we're going to do is get access to the game server and add a listener on it. The listener will return to us hi, or not return to us, but log hi after it starts listening. Now that we have a MaJoDo server running with WebSockets configuration on, I will show you a small WebSockets demo. It's very important to have this graph in mind the whole time because the code replicates this. So you can see the whole diagram in this create room function. Firstly, we are sending a request. We are getting the response which has the token in it. And after that, using WebSockets, we are sending that response, or not that response, but the token back. The server checks it, and if everything is fine, then the user will be joined in a room. The code is detailedly documented, so if you're interested, you can just take a look at the code, which I encourage you to do. Right now I will show you what this code actually does. So this is the client. It's really simple. You have the create room button and an input to send or to broadcast a message to the room. We are greeted with a message from the server saying we are not connected to any room, so every message that we send is basically going into the void. It's not reaching anybody. So let's create a room. You can see we are successfully joined in a room, and every 5 seconds there's an interval on the client which checks for rooms. So let's join that room right now from the other client. Successfully joined, and right now we can send a message like hi, and from the first client we can respond like hi to you too, and that's it. As you can see, when I send a message from the first client, it doesn't show up here because it doesn't make sense for it to show up there, because we're sending the message out to the room. We don't care about our own state because we have it on locally. This is of course a very simple example. This is not even a game, but you can see just that I created the clients and MaJoDo took care of the whole communication. So for the client that uses WebSockets with protobuffers, the functionality is the same. The differences in code are minor. As you can see, the difference is that we are using this message.proto file, which is basically this file, which needs to match the one on the server. So there is another file on the server that's exactly the same, but it's already included in the package, so you don't need to create it on the server. The difference between this and the regular WebSockets is performance mainly, but the functionality will be the same, so I'm not going to show you a demo. You can find the code for all of these on GitHub. I will link it in description. Regarding UDP, we cannot create that kind of an application inside the browser for obvious security reasons. For example, DDoS attacks, data exfiltration, bypassing course policies, and many more. For that reason, I created a stupidly simple Python game which uses MaJoDo as a UDP communicator. I'm going to leave the link to the code in the description, but the code is stacked with comments, so you should not have too many problems finding your way in there. Same thing goes for the WebSockets client. Keep in mind this diagram because that's the only thing you actually need from MaJoDo, is to know how to connect to it. Alright, so let's change the code. It's really simple. I will just change WS to UDP, and I will add a port which my UDP server will use, which will be 1934. I have that on my client, so I'm just using that. You can use whatever port you want. Let's recompile that and let's start the server. As you can see, UDP server is listening on this address port. I won't dive deep into the code of the UDP client in Python because it's the same thing as in the HTML client. The connection or the joining the room process is the same, but the only difference is that here I actually created a small game in which I will demonstrate how the communication works. So let's get started. Firstly, we will create a room, which is as simple as clicking the create button, and in this room we can move around using WASD keys. And on the other client, you can see that we got a notification, or not a notification, but a button popped up, which has the name of the room in it, and when I click on it, I will join it. As you can see, the red one is the main character, or the original for this window, and the blue one is the client. So you can see the first client on the second window because I haven't moved it, but as soon as I move, you can see it. And if I go to the other client and move it around, you can see the changes here also. So yeah, that's it. This is the simplest game possible, and of course you can build up on it. And yeah, guys, that's it. I will leave the link to the code in the description for all of this. And let's just conclude. So MaJoDo is the middleman. You still need to build the clients like I showed you here. If you don't care about the details, you can just use it in its normal form and you will probably have no problems up to the point you want to make something more serious, let's say. Why? Because MaJoDo by itself doesn't implement databases, it doesn't implement advanced error prevention, and so on. That's why I encourage you to fork this repository or the MaJoDo repository and have fun with it. Thanks for watching, and I hope I have been helpful.